Hey everyone, welcome back. Today we're going to be talking about Syslog and traditional logging. What is Syslog? It is a standard protocol and message format for logging system events. Originally developed in the 1980s by Eric Allman at UC Berkeley. Despite being decades old, Syslog remains the foundation of logging in Unix, Linux systems and network device, serving as the de facto standard for system and application logging across the IT industry. Well, that's not entirely true because there is a lot more logging ingestion things now, and the only reason you'd be using it is because you're using a Unix Linux system to catch errors and stuff that's happening in your Linux system, and you'd just be using other log managers or whatever that application uses. You wouldn't be using syslog all the time unless you're checking like kernel logs and stuff like that. But let's talk about it in this video. We have historical context. It was do one thing, do it well, the original design for local system logging. It provided a simple, standardized way for system processes and applications to record events and errors. Yep, like kernel errors and stuff like that. You have RFC 3164 2001 and RFC 5429 or 5424 for 2009, which enhanced the Syslog protocol. And now in 2012, or 2011, we are using transmission protocols like UDP, TCP, and TLS. For why was it adopted? I mean, it was adopted across all Linux systems, right? Linux, Unix systems. It was just a simple text-based format that was human readable, right? A lightweight protocol with minimal overhead. Network transparency for centralized logging, vendor neutrality. Works with any system. So you got Cisco, you got all these different hardware providers. It's going to work with every one of them, right? Well, maybe not every one of them, but you get what I mean. Sort of like the CompT exam. It's vendor neutral, right? Meaning that you don't have to learn one thing. Like, say you're taking a Cisco cert. That would be Cisco based. That wouldn't be vendor neutral anymore because you're doing Cisco, right? But for this, we're doing CySA, which is vendor neutral, which means you can learn any like software or hardware and be good. So just learning on your own as well. But for the message format for the R164, you have priority, timestamp, postname, tag, and message. For this as an example, right? This is what you'd see if you were on a firewall kernel, right? UFW block, and it would show all those blocks. It would show when you configure the console.admin, right? And show that you're getting an index HTML. But see, you have these facility codes, right? Formula is priority equals facility times 8 plus severity. And you have kernel messages. So these are all the things that Syslog can like manage, right? So the thing I was talking about, kernel level messages, user level messages, right? The messages that users are able to see, like mail system, system daemon, security messages, syslog-d messages, right? Printer messages, right? Network news, UUCP subsystem clock daemon, security messages, FTP daemon, NTP subsystem, log audit, log alert, clock daemon, and all these facilities right here. Local use facility 0, all the way up to local use facility 7, right? For the security levels, you have 0 all the way to 7, right? 0 is by far the worst, right? So if you're getting error messages that are 0, right? That means your system is really, really messed up. But if it's just getting error conditions, or warnings, that'll be a little bit easier to fix, right? Debug just might want you to fix something, right? So I'd rather have debug messages than these emergency system is unusable messages, right? And I don't think the test is really going to want to have you remember these. I'm not sure what's going to be on the test, right? But for priority examples, you have kernel emergency, mail error, and local notice, right? For the enhanced syslog format, like the new one, you can see they're adding more like stuff over here, right? And then they have this example of it going to a web server, right? And making sure the login was successful, right? Then you have SDID, which identifies the data structure. SD param name value pairs within structures. Enterprise number ensures global uniqueness. So for local system logging, right? What happens is the system daemons, the applications, the kernel, they all collect this log data, right? And then it gets filtered out with rsyslogd and routed and formatted. Then the log files go to their /var log remote syslog or the databases. Most likely for you, it's going to be going to your var log, right? And stuff like D, M, ESG, right? Those things are going to be able to collect, say, the kernel logs from the var log, right? And you can set it up for remote syslog databases as well. But it's more common to see var log, and that's where your log files are going to be. For syslog, right? That's how you would set up syslog, right? For the include syslog.h, which this looks like it's log info user logged in from username IP address, then database connection field. For the centralized logging architecture, you have traditional hub and spoke model, which is switches are on UDP, right? 514. Then you have rsyslog on 2 different servers, and they're all being collected to this central syslog server. They're being filtered out, they're being stored, and they're making alerts if there's anything that needs to be alerted on, right? For rsyslog, you have this rsyslog conf file, this configuration file. They just make it 4 letters, so it's easier to type in and stuff. But what you have here is you have your kernel logs, mail logs, secure, cron logs. So I mean, you have your emergency, you have your user messages and stuff, remote logging. Say you wanted to set remote logging up, that's where that would be. And then you have your global directives, so what port it's listening on, UDP syslog reception, and all that stuff. For advanced filtering, what you'd have is you would have property-based filters. So like failed login, filter out messages containing failed login. So filter out messages by program name and filter out by host name. Also, you can filter out by facility and severity by doing facility text mail and severity text is an error. So they're looking for the ERRs, right? Then var log mail errors log. So they are finding the mail errors, right? For the custom template, you have custom generated logs, right? Format template, time generated hostname syslog tag, timestamp with JSON output, right? And then you have the template for specific destination. For a high performance configuration, you have var spool rsyslog, talking about rsyslog, right? And making it more high performance so that it will be a lot faster, right? For secure remote logging, you'll configure TLS, right? So you'll load the TLS modules, you'll set up the configuration for certificate management, right? And then you'll do secure forwarding. For RELP, reliable event logging protocol, you will do OM RELP, you'll load the RELP module, and then you'll put the OM RELP reliable server. So this will be the host name of your server, right? And this will be the port name of your server. And then it'll run on to the port that you just set up here with IMRELP for help, for the reception of it, I mean. For Cisco devices, you will configure syslog server logging host, logging trap, logging facility, configure local buffering, logging buffered 16, and that's like the debugging stuff. And it'll log to the console critical ones, so it'll show you any of the critical ones. So this is just for Cisco iOS, which means Cisco, like say, Cisco iOS might be loaded on a network switch. It's just their terminal and stuff that connects to the Cisco CLI, right? For the syslog, the Juniper, JuneOS, you'll have set system syslog host and the IP address. This one you have the source address, and then you have local logging. For a pfSense or OpenSense firewall, you have remote logging configuration, which is system general setup logging, remote syslog server, remote syslog contents everything, status system log settings, log message filters enable. So they're collecting everything and just sending it to pfSense or OPNSense. For network device log patterns, you have common network events that'll happen, routing protocol, interface status changes. So say that interfaces change from up to down, or you're routing them differently. Also security events, logging success, hardware events, which is like VLAN and stuff like that. For traditional log management, you will often have log rotation with log rotate /etc log rotate.d rsyslog. So whenever it says D, right, that means that it's like programmed with a C programming language. So you have your rsyslog.pid, then you have your warnings, right? Then you're telling it to kill the rsyslog.pid, dev null true. Custom application log rotation, you'll have my app, any log, and then you'll rotate them. And then you will systemctl reload my app into rotate. For the command line analysis, you'll do tell -f varlog syslog and then varlog sys messages or so. You'll have multi-file monitoring, right? /varlog messages and all that. Failed password, varlog secure, right? And then we don't really have to go more into that. But centralized analysis script, daily security log analysis. So this will be like an analysis file. So you would want to do like root login attempts, successful logins, top 10 failed attempts by IP, security report for the date. So this is like a automated log analysis script right here. Well, not really automated, but I mean, it's a script that'll do it for you, so it is automated. But what you'd have to do is collect all these logs, and then that would be your security report file. And it's only pulling logs from log secure. You have server health monitoring. You have network infrastructure monitoring, security compliance, making sure that you are in compliance and stuff, audit trail configuration, application integration with Apache Nginx to Syslog, right? Then you have your Nginx configuration, MySQL to Syslog, Postgres, SQL to Syslog, high volume logging optimization you have for rsyslog, UDP TCP trade-offs, lower overhead, higher throughput, no connection state versus the reliable delivery flow control connection management. So this is perfect if you're doing critical log message audit trails versus if you're doing high volume non-critical logging files. Scalability load balancing on the Syslog servers. So you're doing round robin forwarding through these 3 servers, right? With all these logs right here. Hierarchical logging structure, regional servers, central log servers, real time, long-term storage, data lake. Then you have integration with modern systems like Elasticsearch via FileBeat, which you just take your var log messages to the filebeat.yml. Then you'd have syslog to fluent. So to do that, you'd do right here, you do system syslog, and this was telling where the source is going to be to the matching. This is probably the destination, right? Then you have Docker syslog driver, right? So this is running the container and terminal, or this is if you're doing Docker compose, integrating syslog driver into Docker, right? Kubernetes pod, Kubernetes integration. So you have the mount path as devlog, you have the devlog socket, and you don't have any, you have my app.latest. So whatever app that you're trying to get the logs from. And then you have troubleshooting, traditional logging, log message truncation, and then you have the message size and stuff. Network connectivity issues, right? Performance, I'll show you that, guys. So test TCP connectivity, debug rsyslog connectivity. Performance debugging, monitor rsyslog statistics, mod load imp stats, p stats interval 60, which is that's just performance, how good it's performing, right? Log analysis and debugging, you have patterns in logs, time-based analysis, error correlation, performance analysis. Best practices is standardized log practices, centralized configuration distribution. So you're configuring them in a certain way, and then you're just taking all of the .conf files from this into whatever you're running it with, right? For the secure syslog implementation, you have log tampering protection, right? So that you can detect if someone was messing around with it. So you have SOX, which is 7 years, 6 years for HIPAA. GDP varies by data type, so this is compliance and retention. For modern relevance, right, you have why syslog still matters, every Linux system, minimal resource requirements, right, reliability and simplicity, right, and you have standard compliance, right. It actually complies with most of these like stuff like GDPR and HIPAA if you store your logs for the certain amount of time that they want you to store them for. It has integration with hybrid architectures, right? Cloud integration with AWS, Azure Cloud logging handles, and Cloud Syslog servers. Conclusion, Syslog represents the foundation of system logging, providing a time-tested, reliable method for collecting and forwarding log data, while modern logging platforms offer advanced features like full-text search, machine learning, and complex data transformations, and Syslog simplicity. So you need to understand Syslog if you're a system administrator managing Unix or Linux environments, a network engineer working with infrastructure devices, a security professional implementing audit and compliance systems, a DevOps engineer bridging legacy and modern systems. So this protocol is actually still widely used today for Linux and Unix systems, and various people, like I just said, the system admin, network engineer, security professional, and DevOps engineers absolutely have to know Syslog and how to use it and how to get logs from it. So thank you everyone for watching. In the next video, we will be talking more about different log technologies